Good day. So today we will be doing question 7 from the May-June 2023 paper 1. This question is based on calculus, and the first question is to determine the f prime of x from first principles if our f at x equal to negative 2x squared minus 1. So here they asked us to determine f prime of x using first principles. That means we are going to use this equation, and this equation will be found in your formula sheet. Now, we are then going to substitute in our f at x plus h, so it will be negative 2. And where we have our x, we substitute that by x at h, x plus h rather. That's the minus the 1 there, and then we minus the normal f at x. Divided all of that by the h. Limit as h tends to 0. Now let's solve for this. This becomes 2 into x squared plus 2xh plus h squared. When we multiply this out, that's the minus 1 that's there, and then let's multiply out this part of our equation. It becomes positive 2x squared plus the 1, all divided by h. So the limit as h tends to 0, multiplying this out, it becomes negative 2x squared minus, when we multiply negative 2 plus negative 2 and positive 2xh, it becomes negative 4xh, and then negative 2h squared. The minus 1 and the plus 1 cancel out, and we are left with 2x squared. And all of this is divided by h. Our limit as h tends to 0, the negative 2x squared and the positive 2x squared cancel out, and we are left with negative 4xh and minus 2h squared. And it's still divided by h. Then the next step is the limit as h tends to 0. We are going to factor out our h because that's what they have in common. And in bracket is 4x minus 2h, all divided by the h. This h and that h cancels out, and then h tending to 0 of negative 4x minus 2h. So now our h is tending to 0. And if it's tending to 0, when we multiply negative 2 by 0, this becomes 0, and we are left with 4x. So then this is our f of prime of x. As you can see, the moment our equation doesn't have an h, we have dropped the limit as h tends to 0. So the moment we have substituted in that h tending to 0, we no longer need it. So notation wise, this must happen where we drop this. That is our 7.1. Now let's do our 7.2.1. when they are asking us for f prime at x, if our f at x is negative 2x cubed plus 3x squared. Now, here they did not give us any restriction in terms of if we should use first principles, so it's best to not use first principles. So what we are going to then do is then f at x equal to, we are going to take the 3 that's in the power, bring it down, minus 2, and then the x, then 3 minus the 1, plus, do the same thing here, bring the 2 down, into 3, and then we minus the 1 in the power. Then this becomes negative 6, 3 minus 1 becomes 2, plus 6, 3 minus 2 minus 1 becomes just the 1. So that is our 7.2.1. 7.2.2, they say determine the differential of y in relation to the differential of x if our y equal to 2x plus 1 over the root of 4x. Now, how will we approach this? The first thing to do, and the best thing to do, is 2x. We need this x to not be in a fraction. So best thing to do is to say 1 over the root of 4 is just 2. The root of x is just to the power of a half. Solving for it further, we know that that's the half that's there. We know that if it's below a fraction, it becomes x to the negative. So the fact that it's below a fraction, it brings about that negative. Now, let's do the actual differential of y. Then this becomes just the 2 plus this here, the power comes down as we know, multiplied by half, and all to the negative. Now our x is to the negative a half, and we still have to minus the 1 as we do. Then minus a half multiplied by minus a half becomes minus a quarter, and our x then becomes to the power of negative 3 over 2. Let's simplify it a little bit better so that it looks similar to what we had before. So this becomes our 2 minus 1 over the 4 was always there below the division line. Then let's bring this down, and when we bring it down below the fraction line, it loses its negative. So it becomes x to the 3 over 2. doing this further gives us 4. This divided by 2 gives rise to our square root. Let's not forget the minus there. And you can leave it in this form, but I'd like to take in the 4 in here, similar to what we had before. And then this then becomes 2 into 2 minus rather 1 over. If I were to take this 4 inside the square root, it becomes 16x cubed. So that's the final answer. Don't have to take it to this point. You can just leave it there. All right.